Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome. Today we will talk about building micro-frontends, and I've invited Luca here. Welcome to the show, Luca.
Hi, thank you for having me.
So my name is Dohmen. I'm a senior consultant from INNOQ, and I'm also very interested in front ends and how to build good architectures for web applications, especially big ones. But Luca, maybe you can introduce yourself for a second.
Sure. My name is Luca Mezzalira. I'm Italian, but based in London. I'm a principal solution architect in AWS. And in the last 7 years, I explored the micro-frontends topic quite extensively. Not only writing a book, but also building multiple applications and helping customers to implement these architecture pattern across different industries, seeing different challenges and figure out how to overcome them. So it was a very interesting journey so far. So I hope that will continue also for the future.
Awesome. So micro-frontends is already a word where different people have like different ideas what it means, right? But before we get into that, I want to start with your motivation, right? So why are you looking into this topic? What are the problems that you've seen that led you to exploring micro-frontends? Sure.
So 7 years ago, I was working for a company called Dohmen. It's a OTT streaming platform. Imagine, for instance, Netflix for sport. Our focus was mainly live content. It was available in multiple countries that have different needs. And we started to have to grow significantly, moving from tens to hundreds of people, and the tech department obviously was growing as well. The challenge we had is that we don't only developed content for web, but also for living room devices, so set-top boxes, consoles, smart TVs. And therefore, we need a variety of teams that could handle all these challenges. And moreover, the team were distributed. On front end, I work in the past on several projects that require tens, if not even hundreds of people working together for delivering a project. But when you have a monolithic code base, sometimes you have some challenges that are mainly due to the fact that there are some decisions that are pertinent and made at some point in time, but then reverting or changing those decisions across the entire code base is a challenge. And instead, what we were seeing on the back end is that there were distributed architecture that allowed different people to have a certain modularity and flexibility that we didn't have on the front end. So back in the days, I was asking myself, can we figure out a way to have the same flexibility of microservices, for instance, on the front end? And that's basically where everything started.
So one of the things that I think is the most important part of microservice and both micro frontends is the idea of independent deployments, right? So the idea that a team can decide for themselves that they can deploy something without the other teams needing to do something about it. Maybe you can talk a bit about that topic as well, because I think it's very important for our conversation today.
One of the characteristics of distributed system, like if we think about microservices as well as micro frontends, is exactly what you described. So the fact that are independent artifacts. And that is not only helpful from a technology perspective, but also from an organizational perspective. One thing that I have noticed in the past is that very often people forget that architecture is tightly linked with the organization structure. And that is something we cannot forget. Conway's law, for instance, states that we usually design our architecture or our system based on how our company is structured. That is something that was stated in the 70s and is still very actual, in my opinion, and we need to take into account that. The fact that we want to have distributed system, it means that we need to reduce the external dependencies for team, because otherwise it's creating more overhead in coordinating the effort. That it is not only for independent deployments, but is also for sharing libraries and many other things that we're used to do when we deal with certain type of projects. Now, specifically on independent deployments, I think is quite key that we are trying to use best practices that we have learned on the microservices world and apply, if possible, on the front end for defining some boundaries around the Micro-Frontend, input and output, for instance, and then having the possibility to independently deploy at our own pace without the need of massive coordination. That doesn't mean it is always possible. It means that for vast majority of the time, a team day to day is that I'm independent. I can take my decision. I can go ahead and deploy multiple times per day or every day, wherever is the cadence that they prefer. However, there are certain situations where, for instance, when there are features that are across multiple domains of our application, or we have a massive change, like, I don't know, a design system that's changing drastically, we need to do some coordination across team. That is inevitable and is going to happen. But if we can reduce in, I don't know, less than 5 or 10 times per year, then we will have a big success, because every team is independent for vast majority of the year, and they will be able to take their own decision and moving forward with what really matters at the end for a company. So generating value for the users, because we are often forgetting that we are here not only for write amazing code, but also for generating value for our customers. And that for me is the key thing that we need to focus on, especially nowadays, where applications are becoming more complex and users are requiring, let's say, specific features and more rich feature, if you want. And in this case, I think modularize our architecture is a key characteristics for any application for the future.
Yes. So one thing that you also outline in your book is that, of course, splitting up your system into a lot of different systems comes at a cost, right? Like, it's not free to split up your system. You need to integrate it. And we will talk about that at length in this conversation, right? So you have to do a lot of decisions. So where do you come down on the decision on when to do the split? Do you think you should always start with a distributed system like a Micro-Frontends microservices system? Or do you think there is a good reason to start with a monolith and split it up later? Where do you think you come down on that?
Yeah, let's start stating that I don't believe distributed systems are a silver bullet at all. I would say that is more a way to solve, I would say, an organizational challenge. And not only a technical challenge, probably mainly an organizational challenge than a technical one. I think there is a lot of value nowadays working with monolithic architectures, or modular monolith, even better, as was described several times by Sam Newman in one of the free books that he have written on building microservices and monolith to microservices. I think in general, the idea is you need to really think about your context and find which is the right architecture pattern for what you need to achieve. Sometimes for a startup, having a quick turnaround, it makes way more sense than starting with microservices or Micro-Frontends, because you don't even know if your product will reach prime time. And therefore, it's very, very important that when we think about the architecture pattern to implement, we think about what are our priorities. And often for startups, it's validating their assumption or idea, how many customers are interested in that. And then set up the code and the architecture in a way that the modularity characteristics that we discussed before could be leveraged at scale. Because in reality, if we think about architectural characteristics, I think Modularity is one that we spoke about that for several years, and I created a mental model in my head that you can reach a different level. You can have at the code level, you can have at the infrastructure level, you can have at the architecture level and the organization level. And those three things doesn't have to be achieved in the first iteration. That you can start with the monolithic architecture with a modular code base, and slowly but steady move into a more granular modularity on the infrastructure, and then slowly but steady you move towards also the architecture that I believe is the last phase, where you have like modularity on the code, on the infrastructure, on the architecture, therefore the organization based on the assumption that we design our architecture based on organizational structure. If that is true, it means that you can achieve some of the benefit that you can have also with distributed systems, also with monolithic code base. However, require more discipline, require a certain coordination that you might not have to think about when you go further about the abstraction that you are talking about. So I think also with a monolithic code base, you can achieve some benefit of modularity at the code base level, and then that will be your foundation for then moving towards a more distributed system.
Very nice. Okay, so after talking a bit about the motivation, I think we should shift our focus a bit to micro-frontends and away from microservices. So in your book, you wrote that there are basically two big categories of doing micro-frontends, and this also will lead us to what exactly that means, right? So can you explain to us how you can split your application into either horizontal or vertical splits, and what are like the benefits of those two approaches?
When I started my journey in this world of micro-frontends, obviously I struggled to find some content available online, and there weren't many companies doing that. So I had to figure out and create some mental models that would help me and help other developers working with me to visualize what we were talking about. And I created what I call the decisions framework in 2019. That basically is one of the decisions is the one that you mentioned. So the vertical versus horizontal split. And that is the first decision. So when you are approaching micro-frontends, you need to understand how granular you want to go. That doesn't mean you cannot mix and match both. You can definitely mix and match both, but there are certain situations where one make more sense than the other one. So an horizontal split is when you have multiple teams working together inside the same view. So if you reach an home page of a website and you realize that there are multiple teams working on that because your organization is quite large, and you have multiple domains that the homepage is covering, or you have by the type of system a certain level of granularity and reusability on micro-frontends. That is definitely an architecture that I encourage. Classic example, for instance, think about an observability dashboard where you have multiple elements that can in an home page correspond to, I don't know, the throughput that you have, or the error rates and other things. So those are multiple domains that are contributing to provide a final view. And those domains obviously are very likely to be handled by different teams. So in order to aggregate that, you can use an horizontal split where you collect different metrics for provide a view to the final user. On the other side, we have vertical split, where instead a team is responsible for one view or multiple views. Depends from the type of application that you have. So for instance, if we continue with the example of the observability dashboard, you might you go in the home page and you select error rates as a metric that you want to deep dive and understand better how the things are going. So at that level there, you can open a new view that is owned by the team responsible for the error rates, that goes more in deep about the visualization, the charts that you want to display, and maybe you can do some queries and search and other things. So in that case, you can have a mixed approach where you have a team that is responsible for the vertical split of the application, and another one, and the same team is responsible for the smaller view or the snapshot of the view or the error rate that contribute on the homepage. So as you can see, you can have, let's say, both. Obviously, those approaches have different pros and cons. In horizontal split, I have seen more and more people that are investing on tooling for providing capabilities for the team that is, let's say, rendering just a portion of the view, some traction to understand if the micro-frontend that they developed is working. And also there are some challenges around the organizational structure, because imagine that you have, you're responsible for just one micro-frontend in the view that is composed by, 5 micro-frontends. Let's assume this example. How do you ensure that your micro-frontend is working? I have seen companies that are decoupling the teams and having a Q&A session that is owned by the Q&A team for the making sure that the application is working at a whole. And on the other side, I have seen teams that instead are creating tools for making sure that the application or the micro-frontend is working with other micro-frontend in conjunction with other micro-frontends, and therefore the investment around ephemeral environments, where in that case, basically you spin up a snapshot of the system, maybe retrieving other micro-frontends from a more stable version, like staging environment, for instance, and your micro-frontend is working alongside. But as you can see, there are more consideration to take into account when we work with an horizontal split. In a vertical split, it's more likely that you feel comfortable if you have developed single page applications, for instance. That is usually the scenario where if you are capable to develop or you have experience on developing a single page application, that is potentially easier to pick up micro-frontends, because at the end you are going to be responsible for a portion of the system. You can use the whole JavaScript ecosystem without any problem. And moreover, I think is a nice way to ramp up with this idea of micro-frontends. Obviously, it depends what is your maturity level inside the team and what you are trying to achieve. But I have seen successful implementation of vertical split as well as horizontal split.
Mm-hmm. Very good. So one thing that I noticed in a lot of conversations is that there are people that have different ideas what a single page application means. So I think what you're referring to here is a rich client application with a lot of JavaScript, maybe written in React or Angular or something like that, right?
That's correct. So for me, a single page application is an application that downloads just once all the package that needs. And then the only round trip that is doing to the server is for consuming some APIs. Then obviously you can argue that nowadays there are people using lazy loading different chunks of JavaScript. But in the original concept of single page application, the idea was we were moving away from the fact that every time that the user was changing the endpoint was refreshing the entire page. We were downloading, instead in single page application, you download the entire package, and then you at the end you are going to have the entire application sitting on your browser, and then you consume just APIs.
Yeah, but I think like there's still like a lot of movement there, especially with things like Hotwire and technologies like that, where the line is not so easy to draw between server-side rendering and single page applications. But I think we have a rough picture of what we mean, right?
Yes.
Like it's a very client-driven application, probably with routing on the client side and not on the edge or on the server, right?
It could be either way. So the interesting part of the vertical split, for instance, if we want to go ahead with that topic, is that usually the routing part could happen on the client side or could happen at the edge side. I've seen working on both ways. I think architecturally speaking, having at the edge side provides a nice decoupling between the container of these micro-frontends that usually is called application shell and the routing mechanism that if it is on the client side, it might be non-trivial because there are few things that you need to take into account. At the end, you are consuming vast majority of the time, an endpoint for retrieving the catalog of micro-frontends that are available, and then you use some logic that you add in your code for the application shell. The challenge you have if you do on the client side and you are not paying too much attention on decoupling in a nice way this catalog of elements with the mechanism that does the routing is the fact that you need to deploy every time the application shell alongside some micro-frontends that I have seen as an anti-pattern, because basically you are creating a coupling between the container of your micro-frontends and the micro-frontends itself that represent a business domain. If you do on the edge side instead, or server side, it depends if you want to go up to the origin. The nice thing is that when there is a request from the client, the logic running on the server is just retrieving the right artifacts, and that opens up to possible solutions like canary releases, blue-green deployment, or even strangler pattern, if you want, for migrating an existing legacy application or monolithic code base towards a new micro-frontends architecture.
Mm-hmm. Okay, but before we get into that, I would say let's first look into the app shell thing. I think most people are not aware what exactly that means. Can you explain what an app shell is?
Sure. So the application shell is the first thing in a fat client, as it's called, or rich client-side application that you usually download. So when you type your mysite.com, the first thing that you download in that case is an application shell. Application shell is unaware of the business domain, or it should be as much as possible, because that is a common part. And what is responsible for loading the micro-frontends and routing the URL basically on where the user wants to go, and then load the right micro-frontends associated to that. It's also responsible for deep linking that usually comes comes for free out of the box when we are implementing the application shell, and is usually used either with an horizontal or vertical split. So the application shell, when we do on the client side, we can decide to go with horizontal or vertical or both, as we said before. The interesting part is that the very light implementation. There are several technologies that you can handle that. In my humble opinion, usually if you are capable to keep that as framework agnostic as possible, it opens up also the possibility in the future to evolve the micro-frontends without the coordination of having the application shell that is holding you to experiment or try new things.
So let's dive into that topic as well, because I think one thing that I've come across a lot is the question, can I use different frameworks for different parts of my micro front-end, or should I use one the same one for everyone, right? Like, should I use Angular and React mixed, and some use an Angular and some are in React, or should I always use React for all of them, right? Not looking at Angular React right now, right? But where do you see both in the vertical and in the horizontal split with App Shell? How do you see how we can handle that?
I think not only for, despite the architecture pattern that you're going to take on Micro-Frontends, I would say that is a misconception that was raised by the community for several years by now. And the challenge I see, and usually is this example that I made. So imagine that you have a single page application. Technically speaking, you can mix React and Angular. And I remember back in the days when React came out, there were some experiments on that using the React library as a UI and the rest of Angular framework for the management of the state management and the rest of the application. Now, despite you can, it doesn't mean that you have to. Therefore, in my opinion, there are certain situations where having multiple frameworks might help with Micro-Frontends. So when you are migrating, for instance, from a legacy application to a new one, or if you are migrating an application from an older version of the framework to a new one, what you want to do instead of going stealth mode for a month and then deliver something in front of your customer is taking a vertical of your application and start to iterate on that, deploying production alongside the previous application, and start to generate value for the users, because we are going back to the real scope why we are developing code. And that's where I can see for a certain period of time, because I know that is a migration, a mix and match of framework. Otherwise, yes, and another option could be when you are acquiring new companies. So if your company is acquiring another one and you want to immediately see the value that of your investment inside your let's say brand, inside your umbrella, you can do that, and you can easily have another, let's say, technology that is developed by the other company that is living alongside your application. That is another situation. Overall, I discourage this practice unless there are strong, let's say, reasoning behind that, because obviously it's going to have an impact on your users. And at the end of the day, we know that for certain type of workloads, think about, for instance, e-commerce, the first time byte is quite important because it could, let's say, generate more revenue or not. And I know that sometimes it could seem silly, what I'm saying, that 1 second could generate millions in revenue. But in reality, we have quite a lot of companies that prove that is true. And therefore, it's very important that we optimize our application despite the architecture we're using without penalizing our customers.
Yeah. Even though I agree, we should not go to a multi-framework solution, right? Because we are downloading way too much data, and it will also be complicated for things like server-side pre-rendering and stuff like that. I think that a lot of people that are doing architectures for the front end are paying not enough attention to the fact that you already mentioned of migrations, right? If we are going into a situation where we need to do a framework update that is a breaking change, for example, and we are forced to do it across our entire application, then we are paying all the costs that we have for a monolith, right? Because then we need to update all at once, and that might be costly. And the same goes for, like, if you remember something like Backbone.js, that was the first framework I built a single page application with. Nobody would use it today, I would say, right? And sometimes those frameworks go out of style, and we cannot say which one will maybe be end of life by the people behind it, right? It's not very likely that React and Angular will just disappear, right? Because there are so many applications written in it, but we should at least keep it in the back of our minds that this might happen, and that we have a strategy if that occurs, and especially for the framework updates, the breaking changes will be something you should pay attention to, in my opinion.
Yeah, I fully agree. Also because often we need to think about if technically architects and developers are more keen to work with modularity, the business instead is wants to work with agility. So they want to drift the direction in the way that they want. And if we link agility with modularity, basically you have exactly what we are talking about here. So you have the possibility to take the drift of the organization towards your architecture and therefore your code, and shift the way how you are working today for having a better future tomorrow. That is, let's say, probably the key thing that an architect should do, trying to map the business characteristics towards what we are trying to build. But yeah, I agree with you in your mindset and approach.
So one other integration method, so App Shell would be one integration method, right? One other thing you brought up on the client side, horizontal split, was module federation, which is a feature from Webpack. Can you explain what that does on a high level, right? Not on a code level, because that's always a bit bad on a format like this one. What it means and what it does.
Yeah, sure. So Module Federation is an official Webpack plugin that is available from Webpack 5. The interesting part that it does is not mainly for Micro-Frontends. The idea behind Module Federation is the fact that it's a transport layer for bundles. And that opens up quite a lot of opportunities, not only on the client side, but also if you think about cloud or server side, you can still use Module Federation, no problem. The interesting bit of for Micro-Frontends is that if I talk about the transport layer for bundles, bundles could be an independent piece of code, and therefore it resigns very well with the concept of Micro-Frontends. And that means potentially I can use Module Federation for composing my Micro-Frontends, because what it does is exactly this. I take a bundle that is independent and I load inside another application. That is exactly what we want to do with Micro-Frontends. The other great thing that Module Federation does is taking care about the dependencies. Because one of the challenges you have when you deal with let's say your own implementation of Micro-Frontends is how I can make sure that everyone is using React 15 or React 16 or the same version of a framework or library, whatever. Module Federation abstracts that for you, but goes even, let's say, further, providing you the possibility to, let's say, create a scope around the same library with different versions. So if a team wants to use, I don't know, Moment.js with an older version compared to the rest of the application, they can do that without clashing because the scope is different. And that is another great functionality of Module Federation. I think the interesting bit is very foundational. It's going to a level where, yes, you are tied with Webpack 5. There is a version for Webpack 4 that doesn't have the full-fledged features that I described. There is another one on ESPL that I know that is about to be built or in progress. And there are other open source frameworks that are doing something similar without using Webpack. But the overall idea of creating a way that abstract the loading of a specific module, of specific bundle, is pretty good. Because the other thing we often forgot to say about Module Federation is because it's a Webpack plugin, we can mix and match with the rest of the plugins available in the ecosystem. Therefore, if Module Federation generates too many chunks of your JavaScript, you can configure it in a way that instead you have just, let's say, one chunk or smaller chunk, or you want to set a certain budget per chunk. Every chunk has to be at least 15 kilobytes, stuff like that. So you have a great flexibility and is solving a quite peculiar problem of Micro-Frontends.
But does it mean that the build of those different subsystems or different micro-frontends are bound to each other, or are they still like independently buildable? So can I just build the component that does the product view, for example, or is that not possible anymore?
It's totally possible because the whole point of Module Federation is moving away from the concept I need to centralize the build of my elements. I can use Module Federation. There are two concepts that are key: the host, that is the container of let's say another bundle, and the remote, that is what is loaded inside the host. The beauty of this approach is that you can create multiple applications completely independent that are living inside their own world, and then load them together at runtime. And all the loading part is handled by Module Federation. So you just need to deploy, for instance, let's assume that you're using an S3 bucket with a CloudFront distribution in front of it. You deploy your Micro-Frontend tens of times per day in S3. And every time that application shell is loading, with Module Federation, is going to load the latest version of your Micro-Frontend. The beauty of this is you're completely independent despite you're using Webpack, that I know sometimes we think always, we centralize everything with Webpack. Mm-hmm.
Okay, but all we need to align on is the build tool that we are using, right? So we are bound to the same version of Webpack for all Micro-Frontends,
Webpack
right?
5, yeah, correct.
Yes, okay. Mm-hmm. But not Webpack 5.110 or something, right?
No, it's just Webpack 5.
Okay.
It should be retro-compatible. I didn't try that, but I never, to be honest, I never heard anything like that.
Okay, cool. Okay, so a second approach that you outline in the book is using iframes for a horizontal split. So I think a lot of people, when they hear iframes, they think this is like an outdated technology that nobody uses today. What's your take on that?
I agree in certain contexts. In others, it's solving quite a few problems. So iframes, yes, are true, are not new, but are the safest option that we have for create strong boundaries for our and have a bit of control for our code. So if, for instance, you acquire a company and the code that maybe is an old jQuery with other things that you want to put inside your brand new Micro-Frontends application, but you don't want to have the headache to go through the code and build or anything, you take the build that is available currently in the application, you move in your server, and you use an iframe to basically protect the rest of your application. That is a nice way. There is a Micro-Frontends framework called Luigi framework that was created by SAP that is using iframes for isolating the different contexts. And usually what they do is using this iframe that there are not many per view, there are 3 or 4, and they're using that because they are sure that who is developing the code is not going to clash with the rest. And they provide a set of facilities in this Luigi framework for communication part, retrieving the authentication on SAP and stuff like that. The other option that I have seen iframes very useful is on the security side. Because there are certain, industries that require a strong set of securities, and with iframe, you can fulfill them very easily. And therefore, I agree there are several drawbacks on iframe that are quite heavy and so on and so forth, but there are situations where iframes can be a valuable option. The other thing is currently the TC39 is exploring a proposal that's called Shadow Realms. They changed the name recently. And the idea is basically having a glorified iframe, but without all the burden and the problems that we have with the iframe. So you don't have to have the full structure of the window, the object, and so on, but you have like a light iframe with all the benefits of create boundaries around your code.
Yeah, so I've never seen anyone use iframes to integrate within one company, right? But I think especially using it between companies, if you are integrating something from a different company, then iframes are a very good solution. I think a good example for that is Google Maps. That everyone uses iframes to integrate Google Maps, right? They don't realize it because they put in a script source, but it's a good way to really for security reasons split out this application and don't give it access to the entire DOM that you have, right? But I would say it's a rather unintuitive way to integrate within your company where you have higher levels of trust, I would say.
Yes, it's true. But very often in large organizations, I have seen used iframes, despite there are nowadays other options for security reasons.
So one other thing are web components. And I think this is also one of those words where people are not entirely sure what it means. So can you explain what the pillars of web components are?
Yeah, web components are an API standard that is available for developers to create components that are compatible with nowadays vast majority all the browsers, if not vast majority of them, and is providing some utilities like custom components and shadow DOM. And those two things are quite key for Micro-Frontends. So the custom component is possibility to create your own component that contains your code. And the interesting bit you can have in light DOM or in shadow DOM, depends which path you're going to take. And the main difference is the shadow DOM basically is completely decoupled from the main DOM element. And that means basically that you can, for instance, have also some duplication on classic example, CSS style. They are not going to override the one that are available or be overridden by the one of the application, what the application is using. So shadow DOM is basically like a nice black box that is preventing that someone can access it. I think the interesting part of web components is that nowadays, if you're using them, you are compatible with any framework. So if you are doing an effort for building some elements with web components, then you know that if today's React and tomorrow will be Vue.js, you will be able to reuse that part of the code that is that is great. In fact, I also in my book, I warmly recommend them if it's possible to use them for creating design systems, because that basically will allow you to reuse portion of your code and your application, despite the underlying UI framework could change. And that, for me, in my head, creates also this concept of evolutionary architecture that web components can provide. The only challenge I have seen so far with web components for micro-frontends is that often developers are overlapping this concept of components and micro-frontend. And that is a risk, because sometimes you might hear people say, oh, yes, we are using micro-frontends and we have a gazillion of micro-frontends in the same view, but in reality, they're using components. And a rule of thumb that I try to rationalize lately, probably was towards the end of the book, was trying to figure out how I can explain easily the difference between components and micro-frontends. And the idea is, I think the key here is the extensibility factor. If you think about a component, usually the container is providing some context for the component to behave. In that case, you pass maybe, the labels, the localization, the type of behavior you expect from the component, and so on and so forth. In a micro-frontend, you define the input and output. Worst case scenario, you can inject an event emitter, or let's say something that's very, not domain related, but the micro-frontend's own is narrative. He knows how to build, he knows how to render, he knows everything that how to behave, but it doesn't have to be instruct from the container. Therefore, there is no leak of domain outside the micro-frontend. And that is, for me, the key difference to understand if we're dealing with components on micro-frontends.
Yeah, but you already mentioned the problem with CSS, right? So if I take the solution with client-side approach with an app shell, then I might have collisions in CSS class names, for example. So one approach would be to use Shadow DOM, as you already outlined. Are there any other approaches that we can use for getting out of trouble there?
Yeah, and another idea that is, let's say, quite simple to implement, despite you're using web components or not, is using prefix. So if you divide the work that you're doing in multiple teams, every team might have a name or a domain that they're representing. So if they prepend the style, the class name that they want to use with their own unique name, they can then have a uniqueness on their class name. So there isn't the risk that there will be a clash. And that is usually one thing. For instance, I was using Material UI for a demo and for using Micro-Frontends, and I have to make sure that they didn't clash together, because it was Material UI across the entire application, but with different parameter and everything. So I don't want that the same style or class name that was rendering one way in one part of the application could clash with another one. Therefore, in that case, using prefixes, I was able to decouple basically the two styles. And despite I might have two styles that by default would clash together in the application shell, they weren't clashing in reality, because there was a prefix that was, let's say, creating uniqueness on those styles.
So one thing I wondered when I read the book, and also I wondered again now, is how do you handle things like pattern libraries? So if I want to do something like a shared style between all the applications, right? They have like certain amount of code, a certain amount of styling that is shared between everyone, and a certain amount that is like very specific to one part of the application, right? So how do you handle that both in Shadow DOM and in something like BAM that you just mentioned? How do you do that?
So usually in Shadow DOM, you have less problems because are encapsulated. So in that case, you can take your own decisions, and every component that won't clash with each other, because it's not even in the same, if you want, scope of the application. In the other side, I think with BAM is the prefixes that allows you. BAM basically provide you a more granular way to describe the element that you are styling, and going more up to a certain granularity that makes more difficult to have, let's say, redundancy on names. But if that happens, the prefix strategy, it helps a lot, because then at the end of the day, if you're using the same button but with different, let's say, styles or parameter that you want to use, you can do that without any clash, because you are going to basically create, let's say, your way to handle one thing, and then you can supplement, as you described before, with your own style for that specific portion of the application that require different styles. So you can really do mix and match with just this simple implementation.
So maybe this is a bit too deep into the technical part, but if I imagine that you have a page that consists of the app shell and then three sub parts that are that are split, right? That are different parts of the application, and each of them has its own shadow DOM. So, do you include like the basic styling as one CSS file in each of the shadow DOMs and the app shell, and then add specific styling to the sub parts, or how do you do that in practice?
Usually, so if you go in the path that you include all the base element, obviously it's going to let's say have more kilobytes to download for the users, but you guarantee that are completely independent. So potentially, if tomorrow one of the team is using an older version of the styles, that you will still provide, let's say, an independent element that can be updated at some point. The moment that you start to share anything, style, code, whatever, across those three independent parts, then you have a risk that there is a runtime error that you didn't pick up in your environment or in dev environment, because it potentially could be different. So ideally, you need to understand if that is the, let's say, trade-off that you want to take, or if you create more, you spend more energy and more effort for making sure that everything that's loaded at runtime is not going to blow up in front of the customer. Mm-hmm. Okay. It's up to you to decide where you want to spend your effort. It could be as simple as say, okay, I have a bit of duplication. It's 10 kilobyte more. It's not the end of the world. Or no, that 10 kilobyte, I really need them. And therefore, I need to find a way to optimize my pipeline to make sure that I'm not going to create issues at runtime.
So one thing that we did in one project was that the base style was available versioned at a URL, and you could use it in the different parts of the application. And then you can take advantage of caching, right? So at least if everyone is on the same version at that point in time, you only download it once, right? But that's also an approach where you can maybe find like a middle ground between those two approaches.
Oh yeah, of course.
So talking about the server-side part, I think one of the things that a lot of people have never heard about is SSI and ESI, and maybe some people heard about SSI like a lot of years ago. Can you first explain what ESI and SSI are?
Yeah, so SSI and the ESI are server-side include and edge-side include. Those are a markup language that basically are using a mechanism called transclusion. Transclusion basically is an algorithm. What it does is very simple. You have a placeholder element that when is parsed by the engine is going to be replaced by more concrete elements. That, for instance, imagine that you have, a cart element that you are describing with that placeholder. And then when the engine is going to parse that markup element, is going to replace that with a div element and maybe, an image that represent the icon and some links. So that is basically what it means. Those are running either edge side include on the CDN level or server side include on the server level. And I think server-side include is a quite old technology. So it's nothing revolutionary, but allows you to work at the server side and compose multiple elements, because there are servers like Nginx, for instance, that are allowing you to use this technique for composing your page and provide a final output for the user. On the edge side include instead is a markup language that was created back in the days by Akamai and Oracle and a few other companies that is available in certain CDNs providers and not all of them. And the other problem is the one that are supporting ESI sometimes are not even supporting the full implementation. Therefore, if you think about a multi-CDN strategy, probably is not feasible, or if you are thinking to migrate from one CDN that has the full fledged of specification implemented to another one, you might think twice because you don't know if everything is supported. The other problem of ESI more than SSI is the developer experience. That I think is quite important. In ESI, there aren't many companies that are providing a smooth developer experience, so you need to test with against your CDN. Akamai, for instance, is providing a Docker container that basically allows you to test on your laptop how the CDN node in Akamai would render your application, but it's the only company currently that I am aware that is doing something like that. Usually these techniques I have seen used where you have, let's say, more static content on the UI. So, for instance, IKEA used edge side include back in the days for their catalog, and everything was extremely static. They were using edge side include, and when they started to have dynamicity, or they wanted dynamic content or interactivity, they supplement edge side include with client side include. There are some libraries available in JavaScript that basically they do exactly the same thing using transclusion, but on the client side. So you can mix and match those and provide interactivity as well, high cacheability and also let's say span the load across multiple edge nodes instead of going every time to the origin, that usually the origin are way less than all the CDN nodes that are available in any cloud provider.
Very cool. So one thing I noticed when I read the book is that one approach that we at INNOQ use a lot that is very focused on vertical splits is not really described in the book. So I wanted to get your opinion where you fit it into your frame of mind, right? So I added it to this as well. So a few years ago, we wrote this guideline called Self-Contained Systems, where we describe how you can integrate multiple vertical splits into one system, right? And there we focused a lot on server-side routing or edge-side routing. I don't make a big distinction between those two.
Yeah.
Each of those systems delivers its own front end, right? So it's entire stack from database to front end, right? And we integrate those systems with things that we already mentioned, like transclusions or also components in the other system, both transclusions on with ESI or also client-side transclusions that you just mentioned, and also simple things like links between those two systems, right? So they are really independently, deployable, right? They are manageable by one team. Where would you put that into your frame of reference?
But in that case, I would say, are we in front of Micro-Frontends? Because the reality is, yes, you divide by system, but if we say that everything that is divided by multiple systems that are rendered on the client side might represent Micro-Frontend, then where is the distinction between a single page application or Micro-Frontends or whatever it is? So I think the distinction on Micro-Frontends is the fact that you have a map with the business domain, and then you can go more granular or whatever. The fact that and you have like an application shell that I think is one key distinction from Micro-Frontends and other implementation. In your case, you are dividing more in a modular monolith fashion, where you divide some verticals that might or not represent a domain, and then you are basically linking and using web standards for moving between the two. I think not even sure that I would categorize as Micro-Frontends.
That's good to know, because I just wanted to understand where you see the distinction, because in the past I saw descriptions of Micro-Frontends where this would be part of it and other parts where this would not be part of it, right? So it's always good to get a good frame of reference, because it's a different approach to it that solves some of the same problems, because you still can deploy independently and so on. But goes a different route. Okay, so that's good to know. That's helped me a lot. So one thing that you also described in your book is the whole topic of the backend structure. So how is the backend structured to allow access from the front end? And you outlined 3 ways: API gateways, BFFs, and service dictionaries. Can you just give us a brief overview of those 3 approaches and where you see them fit?
Sure. I will start with the service dictionary that probably is nothing new, but I think is very helpful. So a way that I found helpful to decouple micro-frontends from the endpoints that allow basically to run independently the backend part with the front-end part is injecting basically to the micro-frontends the list of endpoints to use with a dictionary basically of services that are available. That allows basically to a micro-frontend to pick the service that they need, and also potentially you can do something even smarter. And every time the micro-frontend is requesting a specific service dictionary, you serve a list of endpoints that are useful for that version of the micro-frontends. That allows, for instance, if you work with API control first, where you maintain the same code and the same contract between the API, then you can evolve independently the application. You don't even have to care about injecting them in CI/CD, as I have seen before, or even create a library that is loaded inside the micro-frontends for handling this part. Because when you have these kind of information that are loaded, you might risk that you, instead of having all the micro-frontends using a specific version of the APIs, you have certain micro-frontends that are using a version, some others another version, and then you need to coordinate the redeployment of this shared library that is a pain, especially in large organizations. So this one is just a runtime way for handling that. Is as simple as a JSON schema or a JSON that is providing a list of endpoints that are specific for a micro-frontend. In the case of API Gateway, API Gateway is well-known way for exposing APIs especially in microservices world, and in that case, you have like your endpoint that are you can, let's say, have behind an API gateway wherever you want, portion of monolith and the rest microservices. All microservices completely up to you, but for the client, it's not a big deal, and that basically also might help where people are saying, oh, if we work with microservices and micro-frontend, we need to have cross-functional teams. It's not true, because you can, at the end of the day, you can use APIs as a nice way for communicating between teams, front end and back end, and maintain the independence of these 2 layers. Then there are people that argue, but I want to have some work that is handled by one team only, can deliver a feature independently and create, let's say, value for the customers. And I agree, that is the favorite way also for me. But there are certain situations like you cannot do that. For instance, in my previous company, we had roughly 40 different targets on the front end we need to manage, and with different technologies. So if I have to create a team that can deliver a feature end to end without creating first-class citizenship inside my teams, I need to have a team of 15, 20 people. That is not manageable at all. It doesn't perform. So instead, if we divide, in that case, in front end and back end, you can have, let's say, more interaction between front end and back end teams. But at the end, if you work well with API contract first, you reduce basically this type of interaction that can work independently against the same API contract. That is not changing every day. And the last one is backend for frontend, where backend for frontend basically is a pattern that allows you to, usually a frontend team, to create a layer that is in between the APIs and the frontend, and they are able to use the APIs that they want, put them together, and serve to their client. Usually are divided by device. So you have like maybe a mobile backend for frontend, one web, etc. But I have seen also people that are dividing per domain. So instead of having one per device, you have like one for, I don't know, the catalog, and one for authentication. And you handle that in that way. It really depends how you want to, how complex is the application, how large is the application, how you are structured. But backend for frontend provides a benefit where Also, if someone is updating, let's say, an API, and you're not aware for that for any given reason, it's not going to cause a cascade effect on the client side. So you can slowly but steady migrate your API on the backend for front-end layer, and also aggregate them in a way that the client can do less round trips and provide a better experience for the users. And sometimes I have seen use REST, sometimes I've seen use GraphQL for this implementation. It's completely up to the team. And often I have also seen one backend for frontend written with GraphQL and use schema federation for stitching together the different APIs in a unique layer that the clients can consume, either mobile, web, micro-frontends, or monolithic application.
Where do you see the responsibility for the BFF? Is it the responsibility of the front-end team that uses it, or is it the responsibility of a different team?
For me, it would be responsibility of the front-end team, because they are the ones that are using that layer and consuming that layer. So they need to know how to handle that. However, I would recommend to have some help from the backend teams, because there are certain, let's say, topics like scalability, observability, stuff like that they have definitely more experience, especially when we are talking about building microservices.
Very cool. So one thing you already brought up, but I wanted to have as our last topic for the day, is the question of feature teams versus component teams. So how do you see team structure, and where do you see it in regards to all the things that we talked about until this point?
I don't have a strong preference. I mean, I work in both, and I've seen both systems working. I think that the context should drive that decision. As I said before, I had, so let's say, the possibility to work in companies where it was impossible to work with features team, and others that I work in feature teams, and it was working extremely well. The problem there then is when you have a limited amount of resource, but the number of features are growing. And then you have a feature team that suddenly it becomes a features team. And therefore, you have to handle multiple of them that are touching multiple points, and the complexity start to raise. For me, it's very important as a tech leadership in general, architects, principal engineers, whatever, that we take regular steps back to understand if our model is still valid. Because often companies start with one way and they stick with that, despite it's not working. And then the problem is, but we don't have enough developers, so we don't hire the right developers. And in reality, maybe the problem is only how the communication structure works, how the company is organized. So either that you pick component or feature team, my suggestion is check regularly if that is a model that is still working for your company, or if the way how you slice your domains is correct. Because as the company is evolving, your architecture has to evolve with the company. It's not something static. It's completely fluid and organic. We need to bear in mind that with the moment that we are designing an application today, in 1 year time, the things could be completely different with the same people or not, because the business drift in towards a different direction from the beginning. And so the assumption and the characteristics of our architecture and the organizational structure that we made a year ago are now obsolete, and we need to replace them with another way. So don't be afraid to change and switch model if you see that there are some challenges, and question yourself. It might be that it create a genuine discussion, but questioning the decision that we were making like 6 months ago, 4 months usually is a good time, but 12 months ago is definitely one thing that I encourage any company to do.
I think those are very good closing words, because I think it's very true for a lot of parts of our system that we should question our decisions, and also think about which architecture really fits our needs, and maybe at the beginning where we are more flexible of changing things, especially change things up when we notice that it doesn't fit us, even though we thought that it would. So thank you so much, Luca, for your time and for your insights. And I wish you a nice day, and all our listeners the same.
Thank you very much for having me, and it was a pleasure sharing with you my perception of Micro-Frontends. I hope that you will enjoy the book, and thank you again for having me.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.